I'm going to explain example 18 on page 353. So let's have a look. First, we have a look at the question. MN is a common tangent. So I have a tangent here, and then I have another tangent there. And first question says KR is equal to MS times RN over SN. So all the possibilities, I'm just going to write them here at the top. KR, so I can do KR over MS is equal to R is equal to RN over SN. Or I can do KR over RN is equal to MS over SN. So I usually write all my possibilities down first, and then I'm going to have a look which one actually makes the most sense. That's what I usually do. So let's start with this first one. So KR over MS is equal to RN over SN. Okay, let me have another try. So I'm now going to try the next one. So I'm going to try the other one that I did was KR. So KR over RN is equal to MS over SN. That for me makes it a little bit easier because that makes it familiar to me, and that actually puts it into the proportion theorem. So actually what they're asking me to prove in question A is they're actually asking me to prove that KR over RN is equal to MS over SN. But now I can't just go and use the proportion theorem. What do I need for the proportion theorem? The most important thing that I need is parallel lines. So I can only use the proportion theorem there if I have parallel lines. So let's go and try to find parallel lines. So that means parallel lines, I usually write them there. I either need an F or a U or an N. So I need either corresponding angles, co-interior angles. It's very seldom that we actually use co-interior angles in cyclic quads as well, and tangent, etc. And then we have alternate angles. So let's have a look. What I have at the moment is I have tangents and chords. That's the only thing that I have. So that's what I'm going to do. So I want to prove these two are parallel. So I either want to prove Rn is equal to K2 or M1 is equal to R2, but that doesn't really, yeah, I can do that as well. So let's have a look. I'm going to go and have a look for this tangent chord. So there's my tangent, and I'm going to go into the bigger circle. So there I can see that N1 is equal to K2. So I'm going to start with, okay, so that's what I want to prove. So I'm going to start with N1 is equal to K2, Y tangent chord. Okay. Then, if I also go and have a look, let me just erase that so that I can show you again from scratch. Then, if I go and again and have a look, then the smaller circle, this is also tangent, and there I can see that N1 is equal to N1 is also equal to R1. That's also tangent chord. Now do you see? Therefore, R1 is equal to K2 because they're both equal to N1. And then I can say, therefore, Km is parallel to Rs. Now, why are they parallel to each other? Because I have proven that these two are equal. And what does that give me? That gives me an F there. Do you see my F? So my reason for that is Why are they parallel? Because I have just proven that my corresponding angles, and what about my corresponding angles that I just proved? They are equal. And now that I've proven that these two sides are parallel, now I can go and say, therefore, KR over Rn is equal to MS over, and why? Because of my proportion theorem, because I've proven that Km is parallel to Rs, and now I'm just going to write it in that form. Therefore, Kr is equal to Ms times Rn over my Sn. And there I have proven it. Okay, so let's go and have a look at question B. So I'm just going to go back, and question B, I'm just going to clear all of this over here. Okay, so I've proven that Km is parallel to Rs, so I'm just going to include that over there. Okay, so I've proven that these two are parallel. Now, question B asks me to prove that MR squared. So let's have a look. MR, and I'm going to quickly see which triangle they are actually talking about. So if you have a look here, I don't have a 90 degrees. Nowhere. I don't have a diameter, I don't have a radius. So I can't actually go and use that Pythag theorem and similar triangles. But MR squared, so I see this 2. I see that 2, that there is 2 triangles sharing that side. So MR is there, MS is there, and MN is this one. So do you see that this triangle has MR, and also this big triangle has MR? So I'm going to use those 2 triangles, and I'm going to try to prove them similar to each other. So let me go and include that again. Make it doesn't matter, it wasn't blue. Okay, so let's have a look. We're now going to use those 2 triangles. So I'm going to work for question B. Question B, I'm going to work in triangle RMS and triangle RMN. Okay. So let's have a look. RMS and RMN. So RMS and RMN. Let's have a look if we can find angles equal to each other. I'm going to do them here in yellow. Okay. So I can go and see that in this triangle and in the big one, they share M2. And then I can also, I haven't actually used this tangent, so that I can also use this angle is equal to that angle. Okay, so let's go and have a look. Just did that quickly. I'll do it now in detail again. Okay, let me just erase all of this. Okay, so let's have a look. Let me just move this up a little bit. Okay. So, I know that angle M2, I usually start with a common angle if I can. M2 in this triangle is equal to M2 in that triangle. Why? It is a common angle. Okay. Then, like I just said, I can show that angle R2 is equal to angle N2 because it's a tangent chord. Okay, let me go back and show that to you. So there's my tangent. Sorry. So there's my tangent. Do you see that one is equal to, if I follow with my tangent, to that angle. And there's my chord. That one is equal to that one. So angle R2 is equal to angle into tangent chord. And then I know the third one is just going to be angles in a triangle. So angle RMS, so they're talking about angle S2. Is equal to angle, and I've RMN. So RMN, they're talking about R1 and R2 in this triangle. And what is my reason? Angles in a triangle, therefore, and I'm just going to write this one in alphabetical order. M triangle M or S is similar to M goes with M. R on the left goes with N on the right. S on the left goes with R on the right. That's angle, angle, angle. Now, once I've proven this similarity, now I'm going to try to write them in proportion because I want to get 2RM squared. So let's go and have a look. Therefore, MR over MN, MR over MN is equal to RS over NR is equal to MS over MR. I have proven it there, but let me just write it down. MRS is similar to triangle MNR. And now we are looking for MR and MR. So there, if I do those two, I can see that MR squared is equal to MS times MN. That is what the asked me in question B. Okay, let's go and have a look at question C. Okay, so question C, they asked me, I'm just going to rewrite question C over here at the bottom. Okay, so question C. They are asking me to prove that MR squared over MN squared is equal to KR over KN. Now what I do know is I know that MR, here is my MR. I know that m or, so what I actually have here is I have a left-hand side and a right-hand side of an equation, don't I? I have a left-hand side and I have a right-hand side. So let's just start with mr. So I know that mr squared is equal to ms times mn. That has already been proven to me. So if I substitute it in there, I then actually know that, therefore, ms times mn over mn squared is equal to kr over kn, in other words. So let's have a look. This actually, one of them go in there. So ms, there's an mn left at the top, is equal to kr over kn. So that's actually what I have to prove. So if I prove that, then I can prove that mr squared over mn squared is equal to kr over kn. That's actually what I have to prove. So let's go and have a look. ms over mn is equal to kr over kn. So let's just have a look. Let's go back here. Okay. So ms, where's my question? So ms, let's just erase all of this. So ms over mn is equal to kr over kn. Now, yes, I can prove that, can't I? Why? Because I have a proportion theorem and I've proven that those two sides are parallel anyway. So let's go and have a look. So I can go and say that in that big triangle, in triangle KMN, I know that ms over mn is equal to kr over kn. Why? Because I can use the proportion theorem, because those two sides are actually parallel, because I have proven that km is parallel to rs. And now I can say, therefore, ms times mn over my mn squared is equal to kr over kn, and I'm thinking ahead here. That's not squared, I'm thinking of those two that's squared already. And therefore, let's just move this up a little bit. Therefore, my ms times mn, I know that this over here, I know that is mr squared. So therefore, I can just go and say mr squared over mn squared is equal to kr over kn. So basically, you can substitute that back into your question at the top. Okay.